Good afternoon. I'm just waiting for the last few to join us, and then we'll be starting. Welcome, everybody. My name's Rosie Sheldon, and I work for TSG Training, and I'll be presenting the webinar today. I trust you can all hear me now. Just a bit of housekeeping. During the presentation, you'll all be on mute. And if you've got any questions, please put them in the chat box for the Q&A session at the end. I'm talking today about the ISTQB AI testing course, and if you want to know more, please do contact us. The next courses are on the 30th and the 25th of November. The webinar is being recorded, as you just heard, and go straight onto our website, shown here, tsg-training.co.uk. So first, I'll introduce a bit about AI and machine learning before talking about how the course fits into the context of the ISTQB family. I'm going to go through the syllabus in detail, but we'll pull out some interesting points to give you a taster.
AI training बोलिए.
Could you please all mute yourselves?
AI.
So I'm going to introduce a bit about AI today, and it's here. When first released by OpenAI, the new artificial intelligence tool, ChatGPT, went viral. Or you've had a go, or maybe you've investigated a tool that allows you to turn any prompt into AI-generated art. AI's come of age, it's all around us. And what is meant by AI is evolving over time. We don't even necessarily realize that there's AI in the products that we use. So what is it? Well, it's the science and the engineering that makes intelligent machines. Artificial intelligence is software that thinks, in inverted commas, intelligently. It's the broad field of developing machines that can replicate human behavior, including tasks to do with perceiving and reasoning and learning and problem solving. And typically, AI models are trained using vast amounts of information. AI can then process the new data and draw new, unique, intelligent conclusions based on that presented information. If you were in Berlin back in 2019, you might have travelled on one of these small yellow autonomous buses that had just been deployed. The city was the first to introduce self-driving buses in Germany. They use AI to make immediate decisions using the data from the recent past. They use sensors to identify steep roads, traffic signals, people crossing the streets, and the vehicles then use that information to make better driving decisions and avoid accidents. Social media platforms such as Facebook, X, and Instagram rely heavily on artificial intelligence for various tasks. These social media platforms use AI to personalize what you see on your feeds. The models identify users' interests and recommend similar content to keep us engaged. And now come to chatbots, and getting queries answered directly from a customer representative can be time-consuming, and that's where artificial intelligence comes in. Computer scientists train chatbots to impersonate the conversational style of using natural language processing, and trains the chatbot how to respond to the various questions. But search algorithms, and they ensure that the top results are the answers to our queries. And search companies usually include some type of quality control algorithm to recognize high quality content. And it then provides a list of search results that best answer the query and offer the best user experience. AI is here. It needs testing. It's a specialist area, hence the course. And as the use cases for artificial intelligence grows, it's inevitable we're discovering new ways that it can improve our lives, and with it, an ever-increasing market. Forbes expects the global AI software market will reach 22.6 billion by 2025. So AI is the broad field of developing machines, and it can replicate human behavior. And that's tasks about perceiving and reasoning, learning, problem solving. And it can be implemented using a wide range of technologies like fuzzy logic and reasoning techniques and machine learning. And this course focuses on machine learning. Machine learning was a major breakthrough in achieving AI, and there are numerous machine learning algorithms, and some of them are shown here. These detect patterns in large data sets, and they learn to make predictions by processing data rather than by receiving explicit programming instructions. And in this course, we're going to be exploring a variety of algorithms during the practical exercises using Weka. And that's a collection of free machine learning and data analysis software tools. Deep learning is an advanced branch of machine learning that uses neural networks inspired by the ways neurons interact in the human brain. And the neural networks, it ingests the data and processes it through multiple iterations that learn increasingly complex features of the data and make sophisticated predictions. And deep neural networks are called that because they are built up of many, many hidden layers. And this resulted in great leaps forward in AI in recent times. And with learning, we're going to compare how conventional systems are developed with machine learning based that development process. So I'm sure you're familiar with developing conventional systems where you start with some form of requirements, and there's maybe a user stories or a functional spec or a technical spec, and they're agreed with the customer and the software developer, who then designs and implements the solution in code. And that's tested, and the code's then deployed to the target system. And with conventional systems, it's relatively easy for us to understand how the system transforms inputs into outputs. But for a machine learning based development process, you still start with requirements, but let's think of them more as objectives. But it's different because now the data scientist gathers and prepares lots of training data and selects the right machine learning algorithm. And then the machine learning algorithm is trained by feeding large volumes of training data into it, and that creates the machine learning model. A model predicts the right responses given the data it's being trained on, but it still needs careful evaluation and testing before it's deployed to the target system. And the important thing is, though, that the deployed machine learning model code isn't written by the developer, it's generated by the machine learning algorithm code. And this process is going to be covered in more detail in the next slide. But before we leave that, I want to highlight that this is specifically around machine learning, not other AI technologies. I'm trying to show you that developing a machine learning system is quite different to developing conventional systems. In an AI-based system using machine learning, training data is used, and that's central to the development process. The training data is central. And once live, the model can then respond to inputs and make reasonable predictions based on that training. So here is the workflow. One's from the syllabus. And as you can see, AI introduces special test levels for machine learning testing. Through this workflow in detail, and it uses practical exercises to support the theory, and delegates download free open source tools and resources to do their practicals. So it's a specialist area, and as such, it's a specialist course that fits into the ISTQB family. Here you can see the Agile, the Core, and the Specialist streams. The courses highlighted in yellow, sort of orange, are other courses that might interest you provided by TSG Training. So initially, the focus after the foundation level certified tester course was on the original core advanced level courses, the test manager, test analyst, and technical test analyst. But then the Agile stream with the newly available Agile technical tester came, and then the specialist stream. This was developed, and many testers have sat some of these courses, particularly the test automation engineer and the mobile application tester. The AI testing course is part of this specialist stream. It's a specialist area, and it gives new knowledge and technical testers and test engineers. And they're typically using Agile methodologies. And as you can see from the arrows, all certifications require the foundation certified tester. The AI testing course itself is 4 days. There's 17 practicals and lots of discussion and multiple choice questions to help you prepare for the exam, which is a 1 hour, 40 multiple choice question exam sat after the course. So it's presented in 4 days, and these are the topics covered. And there are learning objectives against each chapter, but also hands-on learning objectives covering most topics, but not those light blue ones. It's a very wide-ranging course. What I'm going to do now is talk a bit more about different types of machine learning. So this is part of chapter 3, and that's an overview of machine learning. And machine learning takes place in the model generation light blue box that you can see here. There's a train the model box, and that feeds into evaluate the model. And these results are then used to tune the model, and then more training takes place. So it's very, very iterative. And different types of learning can be used for that training. And that's what I'm going to go through a bit about supervised learning, and that can be either classification or regression, a bit about unsupervised learning, whether that's clustering or association, and then reinforcement. So starting with classification, and this is where we're categorizing. Oh, let's keep it simple. And let's say we've got a large retail customer who needs to label tiles from many different suppliers according to what shelf the stock's going to be displayed on, because that's going to be according to size. So the requirements to be able to categorize different size bathroom tiles into big or small, and all the tiles are rectangular and they're labeled B for big, S for small. And so a boundary can be drawn to divide the big from the small. As a result of the training using the labeled data, the model can be given any tile and know whether it's big or small from its width and its length. So when a new tile needs categorizing, it can be done using the boundary to predict whether it should be labeled big or small. The colors immaterial. This is only about what shelf the tiles should be placed on in the shop. And I've only shown the tiles as images to help you understand the concept. The only attributes of importance are its length and its width. And humans can do this really easily. There's only 2 attributes, but AI can do it with many, many more. So classification is essentially categorizing into, in this instance, big or small. But what about regression? Here, to give a concrete example, the requirements to predict the ice skating boot sizes needed for different school group bookings. This can be done using regression. Regression's where the problem requires the machine learning model to predict a numeric output, shoe size, like roughly predicting the shoe size based on the school year, because that's the information you receive. And the training data has the numeric labels, the year group, and the shoe size. So it's a type of supervised learning. So you need your training data, which is the average of the shoe sizes according to the year group. A new booking comes in, and the booking form tells you the year group, and these children are in year 4. And so now the boot sizes needed can be predicted for ice skating. Again, with just 2 attributes, we can do this easily, but AI can use the same principle for many, many attributes. So those are both supervised learning. Clustering is part of unsupervised learning. And this is where the problem requires the identification of similarities in input data points that can be grouped on common characteristics or attributes. And here clustering is used to categorize different types of creatures. Maybe the number of legs is one similarity used for the grouping. So clustering is a form of unsupervised learning, as the training data is provided with no labels. But despite that, the algorithm is able to identify that the training data can be sensibly divided into 2 groups or clusters, as shown on the slide. So, because of, just to make it easy, the slide just gives you 2 clusters, and humans can identify clusters easily with a limited number of attributes, but machine learning can handle large numbers of attributes and create clusters. Association is also part of unsupervised learning, like clustering, and this is where the problem requires interesting relationships or dependencies to be identified among data attributes. So, for example, if you've got a product recommendation system and it's looking at customer purchases, and it might identify associations based on their behavior, the customer's shopping behavior. So here, if a customer purchases pizza and garlic bread, they'll receive a recommendation for coleslaw. But if they purchase chips to eat with their pizza, they'll be recommended a salad bag. And these associations have been spotted from the training data. But whenever chips are purchased with battered fish, vinegar is suggested. Now here, the slide's just showing you 2 attributes, and humans can easily identify associations like this, but machine learning can handle large numbers. And lastly, we've got reinforcement learning, and this is where learning is achieved through a reward and penalty system for the actions it takes. And this gives the software agent autonomy to learn, and the goal is to maximize the total cumulative reward. And this can be done numerically. So if you think about a help desk support system, it might suggest solutions based on keywords. And then the user's asked whether the solution helped or not, whether the suggestion helped or not. So then the useful suggestions can get numerically flagged, that is, they're being rewarded. And that's when the policy is updated that this was a useful solution, do that again. So then the software agent can observe the environment, and it can select and perform actions, and those actions are rewarded or penalized. Machine learning can take place, and it finds its own strategy, and that's called a policy, to get the most reward over time. And once trained, the machine learning system can then use that policy to achieve the goals. So there, I've gone through supervised learning, unsupervised learning, and reinforcement learning. In summary, AI's here. Come and learn more about it. It needs us to develop our understanding of what is and isn't AI and how we can test it. I went through a bit about how AI and machine learning systems are different and why there's a specialist course now introduced in the ISTQB scheme. And the learning objectives and the course content are available on the TSG website, and the syllabus is also there and on the ISTQB website. And I've highlighted some different types of machine learning for AI to give you a taster of what's covered. I hope it's whetted. Forward to seeing you on a course at TSG Training. Thank you for joining me today. Please do put any questions you've got in chat, and I'll do my best to answer them. Otherwise, goodbye. Thinking about when the exam is sat, people sit the exam a little bit later rather than immediately, usually within the fortnight though.